Hi there, thanks for clicking on and watching. Welcome to this video. Hopefully you've done so because you are studying Maths A level, Edexcel, and paper 3 is Tuesday the 21st of June. Here is the advanced information for the stats section of the applied paper. So in this video I'm just going to do some more questions. Do check out my first video which goes through each of the points on here, but in this video just looking at a couple more topics and some questions from the topic tests. So I hope you find the content of this video useful. Do like and subscribe and check out my other videos too. So here's the question from the exam board topic test, which is on product moment correlation coefficients, and there's a change of variables. So to start with, we've got Barbara investigating a relationship between GDP income in 24 countries against carbon dioxide emissions. She takes the random sample of the 24 countries, finds that the product moment correlation coefficient between the two variables is 0.446. Stating your hypothesis clearly, test at the 5% level whether or not then this country, the product moment correlation coefficient is going to be greater than 0. So we're going to be greater than 0, i.e. positive. So stating the hypothesis, H0 when you're doing a hypothesis test with correlation coefficient is always that rho is 0, that there is no correlation, and then you test to see whether what you've got from your sample does go more towards the being correlation or whether it's near the middle and it's going to have no correlation. So H1, because it says here greater than 0, we're testing to see whether rho is positive, so greater than 0. Now if you think about the scale of correlation coefficients, they go from -1 to 1. At -1 we've got perfect negative, at +1 we've got perfect positive. So in the middle 0 is no correlation. So you look upon the table at the 5% level and we've got a sample of 24 countries. We can see here on the scale is going to be our 0.3438, and we're looking for any value closer to the perfect positive correlation coefficient, then that's going to be in the critical region and it's going to be significant. So we have got that 0.446 is bigger than 0.3438. So we do have evidence at the significance level of 5%. So there's evidence at 5% level of significance that there is positive correlation between the two variables. So here's the next part of the question, and what we've got to think about now is the fact that X was the income per capita for the people in the country and Y was the emissions. If you have a think about plotting income against emissions, as the people in a country have more income, they're going to have more things that will then emit the carbon dioxide. So you're going to get a model that goes like this. So it rapidly increases the emissions as we're having people with higher incomes. So Barbara's realized that this maybe model will fit her data, and it's a non-linear model. So she has decided then, rather than doing that with X and Y as the variables, to do log to base 10 of X and call that M, and log to base 10 of Y and call that C. And when she does that, she gets a straight line that goes through. The y-axis intercept is the -1.82 and the gradient is 0.89. You can see M is the variable which relates to the X and C is the Y. So we've got a straight line here. Y equals MX plus C. So when she's done that, she's found that the product moment correlation coefficient between these two variables, which are the ones she's taken the log for, is now 0.882. So that's saying when she gets the scatters, they lie close to that straight line because we've got a product moment correlation coefficient that's even higher than we had before. So explain how this supports Barbara's belief. It's further evidence of positive correlation. Right, so part C, show that the relationship between y and x can be written in the form of y equals ax to the n. So if we start with y equals ax to the n and take log to base 10 on both sides, so what you do to one side, you do to the other, and then we can split this up because it's a multiply and get log to base 10 of y is equal to log to base 10 of a plus n log to base 10 of x. And now we can see this is c is equal to our minus 1.82 plus our 0.89 m. Now that is m the variable, so this n is equal to our gradient, and the y-axis intercept is equal to our log to base 10 of a. So log to base 10 of a is equal to minus 1.82. So using our log laws, 10 to that minus 1.82 must be a. So a is equal to 10 to the minus 1.82, and if you put that in your calculator you get 0.0151, and our n is our 0.89. So putting those constants back into your model, y is equal to 0.0151, your a, x to the 0.89. Okay, next we've got a box plot question, and we've got part of the box plot filled in and we've just got to fill in the rest. So at the start of the box here we've got the lower quartile, which reading off here is 19.4. We've got the median here, which is Q2, which looks like it's 23.6, and then we've got the upper quartile here at 26.6, which is telling me that the interquartile range is the upper quartile minus the lower quartile. So we do 26.6 take away 19.4, that's going to give us 7.2. Now any outliers are 1.5 below Q1, which is the lower quartile. So if we do 19.4 take away 1.5 times 7.2, that gives us that anything below 8.6 is going to be an outlier. And then if we look at the top end, we've got the upper quartile 26.6 plus 1.5 times the interquartile range, then anything above 37.4 will be an outlier. So we've got some temperatures to go on the box plot. 7.6 is going to be an outlier, so that is going to be there. The 8.1 is also an outlier, and then the 9.1 is our next lowest value, so that is not an outlier. So you've got two choices where you want to draw your whiskers to. You can go to the bottom value, which will cut off any outliers, 8.6, or you can go to the next one along 9.1, which is in the data. So I think I'll go there. You go in the middle there, and then you'll do your whisker all the way to the box plot. And then at the upper level, anything above 37.4, but the highest value is 32.5. So we haven't got any outliers at the upper section. So 32.5 is just going to go in the middle there. Obviously use a ruler to do these in the exam, and that is our box plot. Part B is asking us to use our knowledge of the large data set to suggest which month the two outliers that we've just plotted on the box plot have come from. So I've pasted in here a couple of slides from the Dr. Frost PowerPoint, which is quite a useful PowerPoint to have a look at before you do the exam. It's got lots of information about what you should roughly know. You do need to know where the locations are of the 5 weather stations that all the data comes from in the large data set, as well as the 3 international ones, and when the data was recorded. It's recorded between May and October in those 2 different years, and in Beijing the temperature ranges from 8 to 33. So our temperatures that we've plotted on the box plot are at the lower end, and it's in October that we have the lower temperatures for Beijing. So the answer to this for part B is going to be October. So here's the next part of the question. Using the data from the large data set, Simon produced the following summary statistics about daily mean air temperature for Beijing. So we've got these 3 quantities here. Now this SXX, we don't really use that much anymore because we've got our new calculators, but you calculate the product moment correlation coefficient using that quantity, and you can see that when we just take the mean away from all the X values and then square it, that's something we do as part of the variance calculation, but we find the average of that, so we divide by n. So here the variance is going to be that SXX quantity 4952.906 divided by our n, which is 184, and then the standard deviation will be the square root of that, and if you do that in your calculator it does come out to be the 5.19. Now Simon decides to model this with a normal distribution and would ask to find the 10th to 90th percentile range. So if we think of our normal distribution, we've got the mean in the middle, which is here, the 22.6. Now this is the variance, but the standard deviation is the square root of that, so that's sigma is equal to 5.19, and we've just found that out there. But if we think about the interpercentile range, we want the 10th to 90th, so this area here would be 0.1 and this area here would be 0.1, but if you do inverse normal on 0.1 and 0.9, because we always go from the left, so for this area here, the area the other side will be inverse normal of 0.9, you'll get these 2 values here, which come out to be 15.95 and 29.25, and then the interpercentile range is 29.25. Take away the 15.95, which gives you 13.3. Simon wants to model another variable using the large data set. State 2 variables from the data set which are not suitable. Well, I've just got here a section from the large data set which measures wind speed using the Beaufort scale, and you can see all the data is word data. So wind speed is qualitative data, that's word data, quantitative data, so that won't be suitable. We can't do any calculations on word data. Now incidentally, there was a question on the large data set involving you knowing that there were only 3 ways to measure wind speed on the Beaufort scale. Wind speed is measured in different ways, but in a particular section of the large data set it's only measured as fresh, moderate and light. So in one question from an AS paper I saw last week, you had 3 different frequencies and you had to say what would be a suitable variable from the large data set that would represent something that would just be measured 3 ways, and it was going to be wind speed because it was measured either it was fresh, moderate or light. So that was just a paper that was sat last week that you had to know something about the Beaufort scale from the large data set to answer it. But wind speed for this question is qualitative data, word data, so that wouldn't be suitable. And the other one is rainfall, as it is not symmetric. As it is not symmetric. So here's a Venn diagram question. We've got a college where there are 3 magazines. One's about green issues, one's about equality, and one's about sport. And we've got some information on this Venn diagram. Find the proportion of students who read just one magazine. Well, that's just going to be the bits on their own. So that's going to be 0.08 plus 0.09 plus 0.36, so that's 0.53 when you add those up. No students read all magazines, so that's telling us that P is 0, so P is 0. The value of Q, given that the probability of G is 0.25, so 0.25, and then just take away the other bits of G, minus 0.08 minus 0.05 is equal to 0.12, which is Q. So here is the rest of the question, and we've got the probability that S given E is 5/12. So this notation is conditional probability. That line means given, and you can use the formula A given B is equal to the probability of A intersection B all over the probability of B. The fact that we're given that B has happened, we're restricting it so that it's not out of the whole diagram or out of all the outcomes. We're out of the fact that B has already happened, so that needs to be on the bottom. So in this question, the probability of S given E, just putting those letters into the formula, is the probability that S intersections E divided by the probability of E. So where does S and E intersect? Well, that is at R. We know that P is 0 from the other part of the question, so this is going to be R divided by the probability of E, and the probability of E is all E's circle, so that is going to be the 0.05 and the 0.09, which comes to 0.14 plus R, and we're told that that is 5/12. All we need to do is cross multiply now. 12R is equal to 5 times 0.14 plus R. Take the 5 in. 12R is equal to 5 times 0.14 is 0.7 plus 5R. Take the 5R over, 7R is 0.7, so R is going to be 0.1. So R is 0.1. We've already know that Q from our previous parts is 0.12, and our T is going to be worked out now. So we've found that R is 0.1. Your T is just the whole diagram, take away all the other values. So if you do 1 minus everything that's in the circles, T comes out to be 0.2. So the whole diagram, all the properties have to add up to 1, so just take that away. Now in part D, determine whether or not the events S intersection E dash, so that's not being in E, where does that intersect with S? So not being in E intersecting with S is just these two, so that is going to be 0.48, and G, we were told in the question before, is 0.25. Now when you have independent events, 2 rules apply. So for independent events, then you can apply 2 rules. The probability of A times the probability of B is equal to the probability of the intersection, or you can have the probability of the A given B is equal to the probability of A. If A and B are independent, the fact that B's happened is not going to influence the probability of A. Now I'm going to use this one because we can get all the values from the Venn diagram. So the probability of S given S intersection E dash intersection G is going to just be the probability of S intersection E dash times the probability of G. So I need to work out these two things. Well, I've got them up there, haven't I? It's 0.48 times 0.25. And does that equal, where are you in S intersection E dash and also in G? That is just this bit here, which is going to be Q. So does that equal 0.12? Well, if you times them, a quarter of 0.48 is 0.12. So it does equal. So yes, they are independent. Thank you so much for watching. If you're still with me at this point at the end of the video, good luck with all your revision this week for your stats and mechanics. Do check out my other ones, like and subscribe, and I will see you on the next one.